Good afternoon. I think it's time to begin. My name is Nikita. I am from small Estonian company called Plumbr. We are in monitoring business. We monitor applications. And as we talk to a lot of our clients, as we fix their monitoring, as we help them better monitor their production environments, we constantly hear one of the same themes, one and the same mistakes or, well, strange things that people do while monitoring their production environment or their mission-critical applications. And so I have decided to talk a little bit about how you can easily monitor your applications and how you can monitor your applications correctly. As usually the case, that's not one and the same thing. So when I try to find out some good definition, what is monitoring in software operation sense, the best I have found is this, and don't try to read it and don't try to understand it because I haven't understood that. That's complicated. So I have come up with a simple definition, at least for this presentation. What does monitoring mean? When I am talking about monitoring your application, your production environment, you simply want to somehow observe the state of your system. You want to understand, is it in a good shape or is it in a bad shape? If it is in a bad shape, you want to fix it. And that's one part of the story. If I can say that's reactive. And the second part is to be proactive. I know the buzzword. You can use monitoring to essentially understand how you can make your application better so that bad shape will be rarer and rarer. So your application will be in better shape in the future. So very simple definition. Observe, react, make it better for the future use. Okay, so first of all, you have to observe your application to somehow understand, is it in a good shape or is it in a bad shape? Is it healthy or not? And when we talk to our clients and when we talk to colleagues, usually who does monitor your applications in production? Usually, if you are not in some modern DevOps culture, and we still have tons of enterprise clients who do things the old ways, you have some special people, some operation guys, some system administrators who monitors your production environment for you. They have system administrators background, they have operational background, they use the tools that they know, that's Nagios, Stop, etc., etc. So you have pretty simple, pretty easy metrics to have. CPU usage in 90%, for example. Pretty easy, everybody does that. When you start talking about monitoring, always one of the first things that you do, you monitor your CPU usage. Now, let me remind you that the goal of your monitoring, first of all, is to react if your application is down, if your application is in a bad shape. So the first thing that you use your monitoring for is to alert you if something is going wrong in your production. Now imagine that you are a person on the pager, you are responsible for that production environment, and you get paged in the 3 a.m. in the morning, your CPU usage is 95%. So what? Is it a good thing or is it a bad thing? Is it bad or is it good? No idea. It depends. Same with disk usage. Yeah, okay, it's very easy to collect that metric, but what does it mean? How that describes your application health? That you have 2 million active users on your site. That's quite nice metric. That's quite addictive metric. I do remember when we, in the first days of our blog, when we have started the blog on our website, the technical writer who wrote the blog was quite addictive. He hit the publish button, and then he goes to Google Analytics, and they see how many users on the site reading that blog. That's quite addictive. So, 2 million active users on the site. Is it good or is it bad? If you are eBay in the Christmas period, that's certainly bad, because too few. You really hope for 50 million or 100 million. 2 million people on Amazon in Christmas month, that's, well, somehow too few. On the other side, if you are startup and you got hit by Slashdot effect, that's again, it's bad because you do know that you have tested your site with 100K users. Now you have 2 million. You do know that your site is going to crash in 5 minutes. That's bad, but you have to know the context. So again, in itself, 2 million active users doesn't say anything. Average response time for your application is 1 second. Is it good or is it bad? The correct answer isn't even it depends. The correct answer for that question is it doesn't make sense. That question or that statement, that metric is completely useless. And I will talk about that in the future. During last day, we have 578 errors in our logs. Is it good or is it bad? It depends. If a week ago you had 2,000 errors during an hour, that's a good thing. If that errors means, if those errors mean that your shopping cart crashes on every click, that's completely bad. That's completely disaster. Again, we have 7 servers died during the last 4 hours. Is it good or is it bad? I hear some Google employees. I believe they have 700 servers dying every minute. Are you startup that those 7 servers is exactly 100% of your production environment? So the problem with those easy metrics, in my point of view, first of all, they lack context. And the problem is that they do need that context. You cannot understand any single technical metric without the context of your application, without the context of the trend of that metric, the context of the time. Is it Dead Sea season or is it a Christmas fever? You need context. And if we talk about alerting or paging you, because you don't want to sit in front of the monitor and constantly monitor those metrics in order to get know if you need to intervene and to fix your production environment. You want to be automatically alerted when something goes wrong, and you cannot do that with those metrics. Because you cannot really program your monitoring solution or your monitoring infrastructure with all those context-dependent, complicated rules. They change too often. It's too complex. And the second problem with those technical metrics is that they measure the wrong things in the sense that what I mean by misaligned goals is that you don't write application to keep your CPU busy at some specific level. You don't write your application to keep disk mostly empty. I can do that. Please order that kind of application from me. I will charge you a little bit, but I can do that. Your goal of your application isn't even to be fast. Because, well, again, you want your application fast? Okay, hire me. Half an hour later, you will have your application extremely fast. If your application don't need to be correct, it can be blazingly fast. I will just return the constant string from the first level that user requests his your application, and we are done. You will have response time in microseconds. So that's not the goals of your application. That's not what you are paid for. That's not what your customer or your stakeholder wants. You have real goal for that application. Some real goal to satisfy your customer's need to meet some business metrics or to meet some business goals. And so when you want to understand if your application is good or bad, what you really have to do is to observe that application exactly from the point of view of your application goals. Why this application exists? Why? What is that existential reason for that bytes to go from here to here? What that life force that move your electrons in your CPU? And you have to monitor, so you have to observe your application from the point of view from your end users, whoever they are. And so the simplest, useful monitoring, not the easiest, but the simplest, useful monitoring is observe how end users interact with your application. If that's a web application, you have your, for example, access logs from Nginx or Apache HTTP. Note failed transactions or interactions. You want to know when end user cannot use your application for that for any reason, and record response times to understand if that application is fast enough for your application. So the simplest, useful monitoring solution that you can use is your web server access logs, in fact. And then, because every time that you have the number of those failed transactions exceeding some threshold, be that threshold 1 transaction per minute, be that 100 per hour, you do know that you have problem in your production without any context. You don't need that context. You know when your application, when your end user clicks something in your application or uses your application, and what he gets back is an error from the end user perspective in web application case, that may be just, well, 500 HTTP error code, you know you have a problem at hand. You have to solve it somehow. You know that your application is bad. When you page or your pager duty really phones you in the middle of the night because you have 50 HTTP errors, you do know that you have a problem that you need to solve. Exactly the same way when it's common knowledge nowadays, more or less, that application performance does matter. There are a lot of research and there are published numbers that, well, if you increase the response time of Amazon shop for 500 milliseconds, they will lose 1% of their revenue. So performance does matter. So you record that, and again, as soon as you notice that the number of your requests or the number of the end user requests against your application, that your request starts to be slow, you have a problem that you need to solve. Maybe you don't want to alert you immediately in the middle of the night that you have slow requests, maybe, but you have to know about that. But here, if we talk about performance and if you talk about the speed of your application, we have one big problem. The biggest fallacy of performance monitoring is that average response time does mean something useful. Average response time is anti-metric. Here's a very famous example of hence comp quartet, you have 4 data sets. All of them have exactly the same average value, average y value, exactly the same, 7.5. But they're completely different. So average response time means nothing. It doesn't give you any information from the point of view of your end user. Is your application fast enough? Is it pleasant to use or not? What do you need really? You need to record every response time, and you have to have higher percentiles. You have to have 99 percentile of all response time. You have to have 4 nines percentiles, because there is an excellent talk by Gil 10 from Azul about how not to measure latency, where he really blows mind when we talk about nowadays application. You have to realize one simple thing, that one user interaction with your application, that's not one HTTP request anymore, for several years already. The average website that you now use has tens of HTTP requests for one user interaction. When end user clicks a button in your application, your server will record tens or hundreds of response times. That means, now as he demonstrates, that the majority of your user interactions will really hit that 99 percentile of response times as seen from the server perspective. Almost everybody will hit that worst case scenario. In one simple example, in his talk, when you have a simple application of 5 pages, and every page consists of like 20 to 30 HTTP requests, pictures, CSS, some REST services, etc. If you have quite simple application, and 18% of all users, or of all interactions with your application, will in fact experience 49 percentile of response times as recorded by a server. So 1/5 of your users will hit that worst case number. So you really have to monitor, to closely follow your higher percentiles. Average doesn't mean anything. If you remember one thing from this presentation today, that forget the average. Average response time is non-existent. Nobody sees average response time. Nobody. All your users are hit 99 percentiles. So you have to optimize for that. So if you monitor the performance of your application, if you record the response times, you have to really write down every single response time. You really have to plot that maximum values as well. Because if your users, imagine that situation that you have. Let me show you this picture first. So first of all, let's look at the bottom. No, let's look at the top. Let's look at the top. We have maximum response times up to 25 seconds. Here are more or less 4 million requests in total on this chart. And on this chart we have 99.9 percentile of 200 milliseconds. So 99.9% of all requests on this chart finishes in 200 milliseconds. But 1/10%, which in this case is like 40,000 requests, can hit up to 25 seconds. So if you look only on that 3/9 percentiles, well, you're happy. 200 milliseconds. Who wants more? That's perfect number. You don't need anything. But in fact, some of your users will hit 10+ second pauses while using your application. And can you guess what will happen with those users? They will leave you. And you don't see that if you look at any percentile. You have to monitor your maximum values as well, especially if you have a lot of requests where the big numbers come into play. So always plot your maximum values, closely follow your high degree percentiles, 3/9, 4/9, 5/9. They should be your baseline that you optimize against, not average. Not median. Median here is 2 milliseconds, by the way. And plot those percentiles on logarithmic scales, as on the chart below. Because on the chart above, you don't see anything except maximum values. Here you really can understand something. So, let me remind you, the simplest useful monitoring solution that you have, it tracks your end-user interactions with your application, records all failed interactions because you want to action on that, records all response times, plots them or make some analytics on them. So that gives us two types of metrics, because those user happiness metric, however you define user happiness, that's a direct metric that can and should wake you up in the middle of the night when something goes south, because that means your end users are really affected and you want to solve that. When we talk about those technical metrics, they can be very useful when you debug that real problem, because if you are alerted that all your requests are suddenly returning 500 HTTP error, and you see from your technical metrics that your disk is full, you have the most probable root cause of your problem. So technical metrics, don't get me wrong, are very useful for root cause detection, for alert prevention, because if you see that really during your work hours that your disk is starting to filling up, you want to solve it, of course. You do not neglect that. The point being that you do not want to be woken up on that disk alert, because that doesn't mean anything. So direct metrics and indirect metrics. So far we have talked about reacting, about alerting. You understand what's going on right now in your production environment. You react on that, but you can use the exactly same metrics, the exactly same numbers, in order to or as a driving force for improving your application. Because if you know from your history that this particular problem, this particular let me take a step back. When you investigate those problems, end user-facing problems, and you find time and time again that the reason for that failed transactions or the reason for those slow requests are your database queries, for example, or those REST requests to third-party service. You know from history that the most usual case from user-facing problem are the third-party servers that you use. Now you have the perfect opportunity to fix that once and for all, because from the historical data you know what your most common root causes. But now you have a problem that when you come to your when you want to proactively fix your performance issues or your availability issues, you want to decrease the number of those late night pages, you have to compete with actual business cases. And the second problem that I will talk about a little bit later, that when we talk about performance improving, you have to know when to stop, because every application can be made even faster. Let's talk about these two separate problems. So when you go to your manager and say, look, we have this performance problem that has beaten us during last month so many times, we should solve it right now. And your manager, how important is that? And now you cannot explain to your manager why this is important when you talk about CPU usage. He will look at you, how CPU usage is important for my business metric. But when you use your user happiness, however, again, you define your happiness based on that real end user interactions with your application, failed request, slow request, whatever, you really can use that number or that impact as a proxy to why this fix is really needed. Because you can explain, this problem affected so many real users on our site during last week or during last month, and that impact was that big. You can even make one step further. If you group all those requests or you group all those problems, interactions, you group them by consumed services or by users or user groups, then you have even better way to describe to your manager what's going on in your application, and you have much better information, because when you measure that 99.99 percentile of all requests to your application, you essentially put in the same bucket both login screen and some reporting which crunches data for the last half a year and produce a nice PDF report. The letter is expected to run 10 minutes. The first should finish in half a second. When you split that, when you group all those requests by consumed service, you now have much clearer picture of what's going on in your application. You know, okay, we have thousands of requests which last for minutes, but they are all reporting, and users do expect them to be slow, so we don't care about that for now, because we know that there are search in our product catalog which takes from time to time 10 seconds. That's important. We have to fix that. And it is really important to differentiate your requests or your monitoring metrics by users, because we have a very good example. One of our customers, they have a separate, they have a royalty program, a reward program. They have good customers. And after implementing our monitoring tool, they have discovered that that special part of their site, which is devoted to those special VIP users, on average 5 times slower than the public site. So the specialized, targeted environment for very special users is in fact much slower than for everybody else. And that can be even perfectly explainable, because, for example, imagine that you have a shopping site and you have a recommendation engine based on your previous shopping history. We recommend you this and that. So for that, we have to analyze your previous shopping history. Now, who has bigger history? Your new user who doesn't buy anything ever, or your loyal customer for 5 years who buys everything, who buys every week, for whom that recommendation engine will be faster? For exactly that user that you really don't care about. And for users that you do care about, your very loyal customer, that will be the slowest. So you have to monitor by user. Okay, now, when you have this, when you measure the impact of every single performance problem in your application in real user-facing impact, and you have this division by services and by users, now you have the simple trick how to win every single battle with your manager. You invite business people to a meeting, you show them that list and ask them, please tell me which services and which users are more important for you. And that's it. From that day forward, you don't need to prove to your manager ever again, do you need to fix that performance problem? Because you have a total buy-in by your manager, by your business people, that this service is important for us. And if you can show them numbers that this important service impacts 10% of your users, then what have you to prove? You do know that you have to solve it. And when you have that data, when you can assign a user impact on every single performance-related problem in your application, you have the perfect prioritization mechanism. You always know what the next biggest problem that you have to solve. Not by your hunch. CPU 95%, that's somehow too much. We have to get it down at least to 92. You always have the perfect priority mechanism that your manager understands. And he knows when he grooms your backlog, he can really relate, should we make that new feature or should we fix that performance problem? Because he can now measure the impact on the business. Okay. Now, with performance problems or with performance improvements, you always have the danger of such conversation. Okay, now we do understand the impact of those performance problems on our end users. We have to solve them. Okay, how many errors can we allow to our service? Of course, the business people will tell you, stupid. Of course, 0. No problems. All problems should be solved. No downtime. No downtime. 0 downtime, because that affects our business. Please build some 0 downtime deployment mechanism. Perfect failover. We need SLA 99999999999999999, because he somehow knows that 100% is not achievable, but the more nines, the better. And the last question, of course, how fast should I make our application? Faster. But again, now, if you have numbers measured in user impact, okay, we have this error which really affects one person, and one particular person, because he lives under the, I don't know, mobile tower, and his internet is shit. So that's why he always has this problem on our site. Should I fix it? 2 days, 300 euros, one user, he never buys anything. So, okay, let's forget about it. Downtime, again, you now can have the perfect measurement when your site is active, is not, who does use your application in which times of the day, etc., etc., etc. And should I make it fast? Now you really can have a price tag on that. You can measure that impact. And you don't speak about fast and faster. You have real hardcore numbers. The point of my talk today was that you should collect technical metrics, of course, but never use them to drive your decisions about if your application good or bad. Technical metrics doesn't say that. Technical metrics can tell you only 2 things. One, they can help you find the real root cause of your user-facing problems, and 2, they can help. You have to measure them to prevent those failures, purely technical failures. But user happiness or user impact, when you measure that, how these problems affect your real users, that gives you the enormous benefit of objectivity and common vocabulary, common language to talk to your business people. You now really can bring together in the same meeting room engineers, business people, and they will not kill each other when talking about performance. They can really talk the same language, and your business will be much better after that. Real user impact, user happiness, common vocabulary, and well, we can coexist with those people in suits and ties. I'm an engineer, by the way. So that was all that I wanted to tell to you today. If you have any questions, please ask. We have plenty of time. If you don't want to ask any questions right now, then we'll have a couple of beers later, and then you find me and ask me. Or tell me why I was wrong. So, any questions? No? Okay, if you have no questions, there are 2 possibilities. You either understood everything, or you have understood nothing. I really hope for the first. Thank you for your time.